Okay, I think we can start with your presentation.
Yeah, thanks for giving me the chance to tell you a little bit about my personal experience with a couple of blockchain projects that I had the chance to work on in the past 4 years. And if we go to the agenda, I want to talk a little bit about, and this might be a bit basic, what is insurance, what is reinsurance, and how does that relate to blockchain. Then talk about our real-life experience with different DLT platforms in practice in the projects that we were implementing. Talk about the challenges of what it means to bring a DLT insurance application into practice when it comes to talking to big corporations and to the data center guys and ask them, please host my application in the data center. And then finally, a small outlook about what comes next and what would be also the opportunities and the challenges in this very interesting industry where, well, whoever has a great idea probably has the chance to contribute to the value chain as well. And well, we just have agreed, like at the end of each of this block, then it's ideal if you've got any questions, let Gonzalo know, and then he will summarize the questions to me. A word about myself. My name is Thilo Keber. I'm consultant with Metafinanz. Metafinanz is a consultants company in Munich. We've got now about 800 employees. I don't know them all because most of them are always in customer projects. I'm in the customer project currently with Allianz. Metafinanz is Allianz's own company, but we also do business outside of Allianz. And I'm in Metafinanz since 2016, and I had the chance when I joined Metafinanz to work on internal blockchain projects. This was turning very quickly into working with an Allianz team on Allianz blockchain projects. And Allianz is one of the co-founders of the B3I consortium. That's meantime a company incorporated in Zurich. So I could also accompany Allianz in this process of building up B3I with others. And then I was part of the engineering team at B3I, building insurance platform for reinsurance. And on a personal note, I would call myself like a software developer, architect. Don't want to be too specific because there's so many interesting areas in software development. And I'm a DevOps enthusiast, so I would always look at automating whatever can be automated. Right, let's start with the introduction. Talking about insurance. Insurance has a very simple principle, and this is like combining multiple risks into larger sets of risks in order to average expected losses. And then from each of this risk, there's a premium collected, and of course the sum of the collected premiums should cover for the expected loss, and probably there should be a small margin for the insurance, also for savings, to deal with like statistical deviations. That's a very basic business model, and it's also a very let's say, a very mutual and solidarity principle. Multiple entities, multiple people, multiple insured customers go together and cover for damages that happen to some in the group. And I'm pointing that out because it shows that already, like by definition, like insurance is a great opportunity for, let's say, decentralized mutual applications. And insurance companies are like aggregators of risks, and of course they've got like the business model. They must be good in calculating premiums so that on the long time they still make profit, and so they must be really good at calculating the risks that are associated and what premiums they need for covering the risks. And other business model of insurance is typically that the collected funds are invested for interest generation. Now, at this time of very low interest, and insurances need to be very creative about how to generate revenue interest with the investments. And this is like, for example, Allianz, they're partly investing in the sewage system of London, or Italian highways, or San Francisco parking meters, because the financial markets don't provide this interesting interest rates anymore that we used to see in previous years. And then, of course, like insurances need to be very efficient in processing sales and operations, and you need to be aware of fraud, and claims handling needs to be very efficient, etc. Insurance goes back in its root as insurance as we know it today into the 17th century. And this is, funny enough, sometimes reflected in terminology. So if we talk about reinsurance, then we hear something like a request for a line or binder, or writing a line or sign a line. And yeah, this is like the language that was used in the coffee houses of London at, I don't know, Fleet Street in the 17th, 18th century. Okay, let's go to reinsurance. Reinsurance is like an insurance for insurance company, and it's the same principle. If an insurer has like a cluster of risks, let's say an insurance company covers for buildings and it's got a local cluster of insurances in Germany. If there's like a catastrophe in Germany, then the damages might be higher than the insurance is able or expecting to pay out in compensations. Therefore, insurers take insurance as well, and this is done by reinsurance companies. And the example that I just mentioned, this is like a typical excess of loss insurance construct, reinsurance construct, where the reinsurer covers for losses that exceed an amount that the primary insurer, or cedent it's called also, is willing to bear. And this is typically done not just with one reinsurer, because also reinsurers don't like clusters of risk, but this is done by multiple reinsurers. And what I've got here in this graphic, not here, there we see there's different layers. Now, let's assume the cedent is willing to pay up to 200 million in damages out of its own pocket, but is seeking for reinsurance for whatever damages are beyond 200 million. So there is a blue layer where maybe reinsurer 1 says he takes 50% of the risk between 200 and 300 million, and another reinsurer 2 takes the other 50%. And there might be a different layer with everything that's damages that are between 300 and 600 million, where another couple of reinsurers jump in. Typically, reinsurers get for the reinsurance a fraction of the premium that the primary insurer collects. And also the reinsurers, of course, they do their calculations, the underwriting, and they need to calculate that they don't make any losses. in this case, exceed of loss. The example that I just picture here, the cedent doesn't have any reinsurance for damages beyond 600 million, maybe because they're very unlikely and he's taking the risk, or no reinsurer is interested in that case. But if there was like damage occurring of 600 or of, let's say, 610 million, the primary insurer would need to take like the first 200 million, that's his part, and then whatever is above 600 million. So he would need to pay 210 million in this example. And this again to show you, reinsurance is always involving multiple parties. It's not a contract between two parties; it's a contract between multiple parties. And this also means it's contract negotiations between multiple parties. And some of these negotiations are dependent from each other. So like reinsurer 2 could say, I jump in for 50% of this first layer, 200 to 300, for the same conditions that you have with reinsurer 1. That's like a leader-follower approach. So the negotiation is with reinsurer 1, and then reinsurer 2 does the follower. And all this negotiation results in some very complex communication during this negotiation. Okay, there's also reinsurance for reinsurers. That is called retrocession. This is where like reinsurers bundle different of their risks and reinsure it again with other reinsurers. And there's like also layers where reinsurance gets, there's constructs that bring it onto financial markets. For example, with insurance-linked securities. So insurance-linked securities are financial market instruments that contain insurance, and like some investors interested in these kind of instruments because they are very much independent from other capital markets, like from stock market and interest rates, because it's like the risk of losing or not earning is rather bound to natural catastrophes than interest rate changes. What we see here is already reinsurance is very capital intensive. There is only a limited number of reinsurance worldwide, or important reinsurers worldwide on the market. I would guess something like in the range of, let's say, 20 to 50. But this market is overseeded, and these reinsurers, they've got a certain power on the market. On the other hand, when we look at primary insurers, there's hundreds in Germany, there's thousands worldwide. And we also see that, let's say, it's not very fairly distributed, also from the power in a negotiation. Reinsurers can set the rules. Primary insurers are a bit dependent, and therefore we've got in this market, we've got also the role of brokers as a mediator between primary insurers and reinsurers. And typically, if we say blockchain scenarios, we want to cut out brokers, it does not always make sense, because maybe the primary insurers would not be able to negotiate, or some of the primary insurers would not be able to negotiate with reinsurers themselves and get fair conditions. Now, as we heard before, there's lots of communication. There's lots of communication with different parties when I want to buy reinsurance. And we are now in a world, in a business world, where we really still work with old tools. So there's spreadsheets, there's databases, like 1 gigabyte of database files with single risks, for example, part of reinsurance negotiation, and that's communicated by email or FTP for the database attachments, phones, faxes, sometimes a market where people know each other and there's some informal deals as well going on, and lots of manual processing, which means there's certain risks that something goes wrong, that communication is not clearly, and this brings friction in the process. And also, like industry sees that, and there's some standardization efforts. Accord is one initiative. It's also called like a Rüschlikon initiative. Rüschlikon is at the Lake Zurich, next to Zurich, and this is where some big insurers are located in this area. Also IBM, they've got some labs. They've got the blockchain labs in Rüschlikon as well. But even this standardization efforts only like on a messaging level. So the companies exchange or agree on certain messaging layer, but then still there's a friction of, okay, what happens after a message is received? How is it processed? How is it tracked? And the Rüschlikon process so far, I think, is taking more than 10 years up to now. There's big companies talking to each other, and it's still not, let's say, universally applied. Also, it's already some help in the process. And of course, we're talking about blockchain and distributed ledger technology. So there's the big promise of DLT. We're talking about a shared data model. We expect there's reliable communication with DLT, automated processing of messages that are received, triggers that are firing, and the common view on what is the data and what is the state was like, I see what you see, and I know that you know that I see what you see. And as we have seen in most of the blockchain initiatives, of course, like a blockchain comes with an API to use it, and already that is a standardization. And for companies that are not very far in the digital transformation, then a blockchain implementation is progress regardless of the blockchain, but it's already a progress because you agree on using a common API. Okay. Now here, the B3I blockchain insurance industry initiative, we will hear that now more often. This started as a roundtable of representatives from 5 insurers and reinsurers that had an interest in exploring blockchain technologies. This was the first meeting was, I think, in Munich. There's like some of the founding members, Allianz, Munich Re, located in Munich. There was also, I think, Swiss Re and some others. And it was like this round table, very informal, to let's say, okay, we've got an interest. We've all done some experiments with blockchain. Let's see if we can do something together. And this was then becoming more formal with the addition of 10 new members at the beginning of 2017. And then there was the agreement, let's start a joint development of a reinsurance platform for contract negotiation and contract execution for reinsurance. So there was a tender, there was like a team founded, and by March or April 2017, there was a co-development starting with representatives of these different member companies. Again, it was nice. It was starting in Munich, in Werk 1. We had one of these co-location offices, and had very startup-like atmosphere to work on these projects. And yeah, it was quickly getting some results, so that by the end of 2017, we had like a first prototype, and we did a market test with 35 parties. And this was a crude, well, compared to what we've got now, it was a very crude application, but it already showed in the prototype this taking out the friction in the process. And in this market test, there was like primary insurers, reinsurers, brokers, all connected to a big network, and they were simulating like creation of reinsurance contracts, and so some of them estimated they could gain with a system like that in efficiency up to 30%. And this is like a business case, and with that business case, then in the beginning of 2018, B3I Services AG was incorporated in Zurich with the funding and the primary investment of the 15 members of the consortium. And also, like in 2018, then there was a implementation of the platform. Talk about that later. And in 2019, then the first version of this catastrophe exceed of loss contract platform was released. By the end of last year, in reinsurance, we've got like a year end, always means a contract extension phase, renegotiation and extension. So there was like more than 30 contracts were placed on the live platform. And beginning of this year, then this technology was opened out as a platform called Fluidity, and it's always like mentioned as a DLT-based operating system for insurance. So the idea is that on this platform, then other partners can also implement their solutions, but and the platform, the network brings all the players together. If you're interested in B3I, the webpage is b3i.tech. And I will talk a little bit about our experiences in this journey with setting up from like a startup environment to the company with now, I think, more than 20 or 25 shareholders that's doing business in Zurich. Okay, first block of questions, if there are any so far for this introduction.
Yeah, so there is one so far. It is on slide 6.
Mm-hmm.
And it's just a question about whether reinsurance 3, 4, and 5 are the insurance of the insurer, of the reinsurer. So level 2.
No, in that case, not yet. It's really just like the reinsurers in the blue layer, they cover for damages between, if there's damages between 200 and 300 million. Mm-hmm. And if there's damages for more than 300 million, they just go in with this layer between 200 and 300, so they cover for in total 100 million. And then the next layer starts really as again a reinsurance for the cedant, where excess of 300 million is insured. Mm-hmm. So it's not yet a retrocession, not a reinsurance for the reinsurance, but still just another layer of reinsurance for the primary insurer for the cedant.
All right, thank you. We can continue.
Good. Now, real life experiences. Just some time graph here. In 2016, it was the year of the POCs. Probably not only in reinsurance, but also in other areas. There'd been many POCs done by companies. Everyone was interested in blockchain. Blockchain was big hype. And most of these POCs I've seen so far were done on Ethereum networks. As an example, the Allianz, they did a POC for catastrophe swap, insurance-linked security. And also, like when I was with Allianz, then there was a retrocession POC happening on Ethereum or Monax, as it was like now it's called Hyperledger Burrow. So this enterprise Ethereum from Monax company. Also, like Swiss Re, generally, they were all performing some POCs, and these POCs, they showed that there's potential, but they also showed, like in this context of complexity that we have with the reinsurance contracts with multiple parties, then Ethereum-based platforms, they reach their limits. The limits of Ethereum are like partly based in the EVM, the Ethereum virtual machine as an execution platform or at that point was not suited for complex calculations. There's limits like, and these make sense when you have to protect your platform from, let's say, denial of service attacks. You should not be able to execute smart contracts or contracts of arbitrary complexity. But this comes, for example, with limits in the stack depths of calling structures in Solidity. So something like that was found out while companies were doing these tests. And at the beginning of 2017, when B3I did the tender for support in building the platform, then the tender was won by IBM with Hyperledger Fabric. Because Fabric, in contrast to Ethereum, also this, well, there's Quorum, Enterprise Ethereum, but the Fabric approach is a complete different one because, like in Ethereum, the smart contract is executed, let's say, inside the EVM on the blockchain, whereas in Hyperledger Fabric, the chain code is executed, let's say, next to the blockchain, but not in the blockchain. And so you can do much more complex calculations with Hyperledger Fabric than you can do with in Ethereum or Enterprise Ethereum. Also, like the programming on Hyperledger Fabric looks much more advanced than programming on Ethereum with the high-level languages Golang and Java. There had been a version of Hyperledger Fabric, I think it was 0.8 with very good Java support. Then this was a bit discontinued and neglected in favor of the Golang. But also with Golang, you can do a structured and let's say enterprise software development for your blockchain project. And this app prototype that was done with Hyperledger Fabric was part of this market test in 2017. Was quite good, but we also saw when we then compared Hyperledger Fabric with Quarter that gained traction at that time, that Quarter did many things different and right from the beginning. And the most important aspect of that was really the privacy. If you are in a network with multiple insurers and reinsurers, you don't want other parties to know anything about your activities, and you don't even know them to know about the existence of activities. So you could, and this is what was done in this prototype, there was encryption of transactions, so that of course every party had like some blocks, but these were the transactions were encrypted. Nobody could read them except the ones that were part of the transaction. But then still you can count transactions. And if you know who's the biggest reinsurer, then probably you can count his transactions and still get some insight. So a solution where, let's say, information about transaction is leaking out to all parties was not what we had in mind. Of course, now Hyperledger Fabric, they've got the channels as like mutual subchains or blockchains between mutual parties. But then also, if you think of a scenario, a channel is something like a Slack channel. If I get invited to it, I see what happened before I joined, and even that is not always desired. So the approach of Quora, where it starts on a pure need-to-know basis, was really what was appealing about Quora. And then also with Quora, and I come to that later, the developer experience was a complete different one to Hyperledger Fabric. So cutting it short, by the beginning of 2018, then we started to re-implement re-implement the solution based on Quora, which was a good decision. And this led to the first working version of the network, the software in the network, by the middle of 2019, and this led to having live contracts now on the platform by the end of last year. In the following slide, there's some comparison that's biased and opinionated. That's all my opinion, and we can talk about it. I just want to go there into a bit detail, and wherever we've got this. These icons, the smileys that are not displayed here, these are really smiling smileys. So if you talk about privacy, yes, there is some privacy with enterprise Ethereum and solutions like Quorum. There is some privacy in Hyperledger Fabric channels, but this strict need-to-know approach of Quora ensures that there is privacy by design and not as let's say, a patch or an addendum to a public system. And we always have to keep in mind blockchains are by default public infrastructures, and that's good. So a blockchain means there's unrelated transactions combined in blocks that are different, that are distributed to many parties. So it's like, in my view, a very public infrastructure. If you talk about the runtime environment, well, as I said, the EVM has certain limitations for enterprise Ethereum. Hyperledger Fabric, we've got the Golang runtime, and like if you deploy chain code, then it started in Docker containers, so that's good. Docker is not bad. With Quora, the runtime environment is the Java virtual machine, which I can also put into Docker container. And advantage here is really that big corporations, they know Java. They've got their processes for Java, and they know what Java versions are accepted and what not. So JVM is like more common technology to the big enterprises. Talking about development environment, this development languages, Java Kotlin on Quora, Solidity on Ethereum, Golang, then it was coming JavaScript, and now I think it's Java again as well for Hyperledger Fabric. as I said, big enterprises, insurance companies, financial companies, they probably have a big pool of Java developers, a minimum. There is now more and more Kotlin developers available on the market as well. Golang is probably you have to seek longer for Golang experts. If you look at the state persistent, so where's the state persisted, then on the Ethereum, it's the file system. It's like files on the file system. Hyperledger Fabric is using a database for the state, the level DB or CouchDB that's pluggable, whereas it's not completely pluggable because you have to adjust your chain code on specifics of this database implementation that you're working with. And in Quarter, it's like an enterprise SQL DB. Again, because big corporates, they've got enterprise SQL DBs and they know how to maintain them. So the choice when they designed Quarter was really to use technologies that are used in common in the enterprises. If we look at we talked about attachments that might come with contracts, file persistence in Ethereum. It's like off-chain planetary file system if you want to, but if you don't want to spread it around, then probably you've got some off-chain storage on a shared, cloud bucket and store hashes on the blockchain. Very similar with Hyperledger Fabric and R3 Quarter, they support this concept of attachments up to a certain size that are also then stored in the vault in the enterprise database. The peer-to-peer protocol with R3 Quarter is AMQP over TLS. Again, you find some standard components for that technology in the enterprises already, and maybe it's a bit less frightening to enterprise security officials than a peer-to-peer or gossip protocol. And then one differentiator as well is if you look at where does my crypto material reside in the Ethereum world, it's typically in some kind of a wallet. So you've got your MetaMask with your keys as a browser plugin or a wallet. Hyperledger Fabric has like crypto material that's used for signing transactions that's maintained at the client level, but there's also like crypto material on the node level. And Quarter doesn't have any notion of a client as such. The organization identity keys are located on the node level. And this is what's used to sign the transactions. There's no other layer. Okay, questions so far?
Yeah, actually, can you hear me, Thilo?
Yes.
So I like very much this slide. It contains interesting rows I didn't think of, but which make perfect sense. I have one question. When I looked at the examples, if you say you want to implement something of a certain complexity, a business logic, so the level of abstraction, I think, would be one row a computer professor would look at. What's your feeling? So I had a little bit the feeling that Fabric is very low level, so because it's essentially a store, and you can do arbitrary things in your preferred language, which is nice, but it's hard to say, to validate what's going on. So Ethereum is very limited, and if you look at the examples that are typically circulated, it's easy to say what's going on. So it's very familiar with object-oriented programming. And when I looked at the example of Quarter, it seemed to me very explicit in the sense you have to get flows and you have a lot of builders, and it's very verbose. Do you see that? It is only the impression if you see the first examples, and later on, if you have bigger examples, you you have layers of abstraction in Kotlin which hide complexity from me? Or does it really require me to think very much in terms of flows and sending messages and signing stuff? You know what I mean?
Yeah. I think R3, they've done already a good job with some abstractions on the flow level, like the finalization flow that takes care of getting a notarization for your transaction and writing it into the vaults and distributing it into the remote vaults. That's already a good abstraction of all that. Yeah, Quadra is complex, but R3 is already doing a good job in making it more bearable. If you talk about, let's say, what do the states look like, it's what we really liked was that states in Quadra are like objects, and you've got classes, and what we even could do was like annotate these classes with JSR, what's this, 103 annotations, to, for example, have a better validation of the content of, for example, certain fields. So if you want to make sure that, talk about something that's probably not part of a reinsurance contract. If you want to say an address has to follow a certain pattern, then you can do that with an annotation in Java, like you would use it for Hibernate, and you can even make this annotation validation part of your data validation in the contract. So the Java world offers like many useful tools for your modeling of your states.
Okay.
But on the flow level, yes, I agree. But also on Hyperledger Fabric, if you've got some, let's say, more complex, what is called the approver. You've got a transaction that needs to be not approved, so there's a different term in Fabric. Also, you need to know in the client SDK exactly what you need to do in what sequence if you want to, for example, select signatures. And blockchain is distributed ledger is complicated per se, but on the other hand, if you think about system development with distributed ledger, in the end, the customers, the users, the end users, they are not interested in your backend, interested in a fancy user interface and a good design up front and performance. And the data center guys, they're interested in how can I structure the layers of this application into my firewall zones. I think the blockchain development makes maybe maximum 20% of all the software development efforts that you have when you build such a system.
And so I also thought a little bit about use cases, but maybe you can answer it, or maybe it's boring for the students. But what I see, for example, we were thinking about trade financing, yeah, so that you have typically the idea of tokenizing trade, so that two parties do this, and they don't know the other parties later on which will insure the trade. Yeah, or we had this simple example, I think the toilet example, yeah. I think if I know that I'm a contractual discussion, so I communicate with a trade partner, it's clear, yeah, who are the involved parties, etc., and who should sign it. But it was not clear to me if I now more or less use tokenized assets and we add value to it by insuring it or by financing it. Do you know about examples like this where you more layered idea of tokens and observers of tokens and do trigger certain stuff? Or would you say this is not suited example?
No, I think it's more like the latter. On Quadra, you do transactions with other parties you know.
Okay.
you know by identity. So I send a transaction proposal to another party that I know by identity. Yeah, if you talk again about financial applications or insurance, maybe that's even like a regulatory must. I can't just send a transaction proposal of a certain value to someone where I haven't done any KYC with, or nobody else has done the KYC with.
So with my words, more or less, you would say, okay, so we still stick to this message oriented technology. So that messages are being sent, and that more or less the result of receiving the message, the states, they are now replicated in your data structures that impose a certain shared data structures with copies of the involved parties, but you don't have so much the idea of a centralized data bank or a decentralized data bank.
Exactly.
Okay, so therefore, then that was also my guess when I read it, that this is more or less the idea. That you don't want to share everything. You want more or less have a failure tolerant and structured information exchange with methods.
Mm-hmm.
Okay, thank you.
All right, so students have other questions as well. The first one is that you've talked about initiatives between several insurance companies. However, you didn't mention any official governmental institution like the German Federal Financial Supervisory Authority, BaFin. So is the case that these initiatives and these DLT platforms that they build together do not need an official institution to oversee the correct functioning, even though it's in the insurance industry?
That's a good question. In this implementation that we have so far, bear in mind it's the blockchain or the ledger is not the law. So if you have contracts that you have agreed on the blockchain, it's still you need some accompanying paper printed out or signed with ink or digitally signed. Well, the digital signature you can do within the flows. But there will always be like another reference between the parties. Of course, you have the insight into what is the status, and you might have some paper contract that says we agree that the status is what's inside a blockchain, but you can't do without all this, without any of this collateral. And like if some company comes for an audit, if some regulatory comes for an audit, they would still find whatever they need for the audit. But on the other hand, it's really because with this need to know concept of Quada, it would be possible to say in the moment there's an audit and the auditor is also an organization in the Quada network, I could make the states, the contracts available to the auditor, and again, they would only get what they need to know for the situation that they're auditing. So it's like a next step is to include the digital auditor. In the current status, the auditor is still physical.
All right. The next question is about the negotiations that these industry entities have. One of the students is asking if you have any example of the content of these negotiations between these entities.
Mm-hmm. Let's say typically you talk about region, apparel. There could be that the primary insurer wants to insure a set of house property contracts for the region Germany against hail and storm. So that's the peril. And then there's a list of, this consists of the following 500 contracts, and the total premium has a value. Then you've got like the attributes of from when to when. Typically, you've got also in these contracts terms and conditions. There's always terms and conditions, and it's also a challenge to formalize them because everyone wants to have its own terms and conditions, but you want to standardize on those as well. And then there is like, well, the condition is then in the easiest case, what is the premium? The premium, what's the premium? It's 5% of total premium income from this contract. As an example, and then you've got some other parameters, for example, rules for reinstantiation. So, for example, if I insure something against this hail and storm, and then something really happens, this initial contract is then finished with the event and with the damage, but there's like rules for automatically renewing it. So that the coverage doesn't get lost, and there's also like contents about the terms of this automatic renewals. But in this exceed of loss, it's pretty simple still. If we talk about reinsurance, for example, life insurance, then the content of this package that gets insured will really be also consisting of every single life insurance that is inside this package, because the reinsurer will want to be able to look at every single of these risks when he does his calculations.
All right. The following question is, you talked about limitation of Ethereum with respect to computation. So smart contracts written in Solidity have a limitation on the computation that you can do if you are using the public network, right? And you said that Corda has another approach that allows to compute more complex calculations. Could you give an example of these calculations when they are very, very needed, and thanks to Corda, you are able to compute them, and with Ethereum, you wouldn't have been able to do so?
Mm-hmm. Well, the example that was found there with Ethereum was really if you go into in this retrocession, and it had to do with looking into every single contract. But like a retrocession is a reinsurance for reinsurers, and usually you've got a set of reinsured risks that are then subject to this retrocession, and this reinsured risks, they have some level below them as well. And it was then in looking into iterating and looking into depths into all of these reinsured assets where they had to go to the off-chain calculation.
All right. And the next question is, maybe you could give us a summary of why companies usually prefer a DLT such as Corda rather than using a blockchain. Maybe in a few words for recapping and more concise this slide that you had before.
Mm-hmm. I think that the main reason is really this privacy by design. In Corda is not a blockchain. Corda does not distribute blocks of transactions to all involved parties, but in Corda, the details about transactions are only distributed to the ones involved in the transaction. Mm-hmm. But still with, like, if you've got some follow-up transactions, the protocol makes sure that everyone receives whatever he needs to validate whatever he needs to validate. And this is like the big difference in a blockchain. The state of the complete blockchain is always validated on each validating node with every block that comes in. So I don't need to do any validations in the moment I want to do a transaction, because I know the ledger is already in the it's intact and it's validated. And in Corda, it's just the opposite. In Corda, you validate whenever you receive the data about the transaction, and you don't know about the global state at all. You just validate whatever sub-branch of this transaction tree you need to look at. But it's really like just a distribution of transaction details only to involved parties. That's like the main differentiator.
All right. And the last question, which I think might be covered in this set of slides that you have in challenges, so you let me know if you will answer this soon, is the fact that Corda does not have a blockchain. A blockchain in itself has some properties that are very nice for certain applications, right? So the fact that Corda does not have a blockchain, does this carry with it some disadvantages that with the features that Corda has at the moment lacks?
No, hang on, I need to think about it. Can you give me a more specific example there?
The student hasn't specified anything, but I would say, I think maybe this question we could make it after the lecture, because then you would have to think what are the benefits of using a blockchain, and then the benefits of using Corda, and let's say the difference, if there is something that the blockchain does that Corda can't, right? But I don't know if you are up to...
Well, there had been on QuadaCon last year. That's like the annual conference where like developers and business people meet up. There had been one talk where one of the Quada employees, he demonstrated how you could implement a blockchain with Quada. It's like the worst blockchain that you have seen ever, but it was like the proof of concept. If you try hard and got lots of resources and time to waste, then you can even implement a blockchain with Quada. But I think in general, it's like two different, also philosophically different approaches. The blockchain lives off its, how would I say it, anarchy. An ideal blockchain is the one where I can create an account just like that, nobody's involved, and I can start dealing with the blockchain like I can do with Bitcoin or Ethereum. Okay, talking about regulation, sometimes it's wanted, sometimes it's an annoyance, but this is like a blockchain, and that's the advantage of a blockchain: the freedom, and the consensus of the miners who decide on which direction this will develop. And an enterprise distributed ledger technology like Corda is highly regulated. It's built for being highly regulated. You can only participate if you've got a known identity. This identity is approved by a doorman. Otherwise, you don't have a valid certificate to interact with others. But this also gives like the security and the confidence that some other parties need to do certain transaction with you. So it's really like two completely different approaches.
Mm-hmm. Yeah. That's a very good answer, actually. Okay, so then this is it for the questions for now. So let's continue with the challenges.
Okay. Yeah, you need to tell me when it gets too much into details, because now this gets into details. Okay. What are the challenges if you decide you want to build some enterprise blockchain applications? What challenges will you have to see, and which ones did we find? First, there's a non-technical one that I want to mention nonetheless. It's about governance. And this is what we talked before. On the public blockchains, we've got a different governance. We've got this governance of the distributor, the committers and the miners. They form this body that decides which direction is it developing and how will the network look like. In a regulated enterprise blockchain, you need to have a body for governance. You need to have someone who thinks about a legal and regulatory framework. In the case of B3I, it was B3I who's developing the application. It's not the community itself that develops. You have to think about membership, and not only membership in the way to say, okay, I've got a valid certificate because my identity is proved, but in a business network, there might be other membership rules for, like, you have to pay a fee to become a member. If you want to be a member of B3I, you need to be a member of the club. But if you're a member of the club, then you can use the application, you see the other members, and you receive the software. If you leave the club, then you won't be able to use the software anymore. And for that also, you need to think about how is the network operated? Do we want to have our own notary service? Do we monitor the health of the member nodes in the network? You might also want to think about metering and billing. Metering is like counting transactions. For example, for billing, but there could be other possibilities for billing, like flat fees for the membership, but then you have to have some tools and applications how you can validate membership so that nobody is in the club who doesn't have a valid member card. And for that, also there's some ideas on the quarter solutions page that I have written here. In quarter terms, it's called a business network operator. So a business network operator typically is an entity that operates notary services, operates membership services. There might be like a business network software body and a business network governor that decides what will be the direction of the software development. But that all needs to be set up. It's not that we can develop a software and set the rules, because it's all involved parties need to be involved, otherwise it won't function. If we want to build a distributed system that is owned by some single entity, then it won't work anymore, and nobody will be interested in it. So that's like what I see as the first challenge. Think about the governance and implement solutions for it. And that's non-trivial. But then when we talk about the operation of nodes in a decentralized network, then it gets really challenging. It's just asking the question, who is running a node? B3I with its 30, I think it's in the range of 30 entities on the network right now. Not all of them run their own node, because some of them are not able to, some are not interested in, and some are not mature enough to run their own node. Because running a node requires a certain technological skills and a certain database infrastructure. And so although we want that every party in a distributed network runs its own node, to have this distributed character still there, practically there will always be a need for node hosting. And we saw this at B3I, where B3I is offering nodes as a service for some of its members who don't want or are not able to operate their own nodes. But we also saw it with other initiatives like the Marco Polo trade finance network. They've got also like a service provider who offers node hosting. It would not be good if all the nodes, the hosted nodes, were located with the same service provider, because then you've got a central system again. And there's also something talking about IBM and Hyperledger Fabric. IBM offers node hosting At the time when we looked at it, it was like an offering where then these nodes were hosted, the Fabric nodes were hosted on some infrastructure that's based on mainframes. So that was nice for joking about blockchains on mainframes. But like if 90% of the system is then located within the IBM data center, then something is wrong as well. So we need to look at least some reasonable distribution of self-hosted and hosted nodes. And if we host nodes for other organizations, we have to think about is this a temporary solution or a permanent one? And if it's a temporary solution, there needs to be a path for the repatriation of the node into the client premises. So this would mean we need to be able to provide the crypto material, the keys, to the client so that he can set up his own node with his own keys. And we need to be able to, let's say, migrate the vault contents, the database, to the client. If I was a client, I was offered node hosting, and I would not have an option for transferring the state of the ledger into my own data center at a later time. I wouldn't be interested in it because then I'm locked in, and it's like not your keys, not your not your data. So I want to be able to own my keys. Another challenge is like how are the artifacts, so the developed artifacts, distributed. It's clear that if you run a system, a network over an expected period of, let's say, 10 or 20 years, there will be different software versions. Oh, that's the next point. But how can we distribute this software, even if it's just like the initial version? Is it per source code, or do we build jar archives that are then distributed to the parties, or even Docker containers? For us, Docker containers were like the preferred way because it's then not only the jar, but also some environment about how the jar is executed and how we can monitor, or the client can monitor, and how the logs are configured, etc. Coming back to the software lifecycle, there will be software updates, but in contrast to a central system, I don't have any control over when these upgrades will be installed, or the upgrades will be happening on the different parties. So even if I've got a version 2.0 of my core app and I distribute it to all the parties, I can't force big insurance companies to install it next Friday at 3 so that next Monday everyone's on the same level. So I need to appreciate that there's always, there could always be different versions of the software deployed to different nodes, and still it must be reasonable, interoperable. And this is like a challenge from development, but also from testing, to find out all these different scenarios that could happen when there's version upgrades. But yeah, it's nobody should have the idea that it's like a big bang. Every node in the network is updated at the same time, and next day everything works again. And also, like if you've got larger networks, let's say with hundreds or thousands of members, you must also appreciate that at any given time, a couple of these nodes are not reachable or down, and you can't also rely on it. Even if you had something like an update transaction that you distributed over the network as a broadcast, you can't rely on the fact that this is applied at the same time. So that's a challenge. Another challenge is like dealing with the guys in the data center, and I'm joking about it. It's a very important job. To be responsible for the security, for the network security, but it's also, these are the guys that say no to whatever we want from them, because everything that's new and is a change is a risk to a system. So they've got some traditional expectations, minimum expectations, and traditional expectation is that you have multiple network zones, like there's a DMZ, a demilitarized zone, where systems are located that can be reached from outside. Then there's maybe an internal zone, and persistence is databases are located in a different network zone, and all these zones are separated by firewalls. And like the typical expectation is that all external connectivity, like every socket connectivity from outside, is terminated in the DMZ. We have seen some requests or some questions about deep package inspection on the data that's going through the firewall. And there's like a general good practice to say, if I've got secrets or keys, I don't want to maintain them on the machine, but I want to have them separated in some vaults, so that even I don't find them on the backup of the machine if there's one. And the reality with distributed ledger technology is that, let's say, most DLTs that I see, so they don't really support DMZ termination. So if you've got a gossip protocol, yeah, then you could probably, maybe you can set up some relay node in the DMZ that receives the gossip and transfers it through the firewall over gossip protocol into the internal zone. But I've never seen such a setup documented. Enterprise, Quadra Enterprise, they thought of things like that. So they've got the Quadra Enterprise brings the Quadra Enterprise firewall, and they've got like components like what they call the float that can be located in the DMZ and is contacted by the bridge that's in the internal zone. So the bridge opens a connection to the float. The float doesn't know anything about the bridge. It's just contacted by the bridge. And this is like an architecture that's like accepted by the network security officials. Like talking about this deep packet inspection, the idea is you can look into payloads of whatever goes into your data center to identify hostile content. Now, no, I don't want to have anyone looking into my packages when I've got AMQP over SSL, because that's what the SSL encryption is for. It's really an SSL encryption, and that's something that like needs to be explained. No, there won't be any deep package inspection on whatever we get into the node. And like Quadra Enterprise and also Hyperledger Fabric, they support like HSMs, hardware security modules, separate entities where the crypto material, the keys are stored so that they're not stored on the file system of the node. Again, something to look out for. Okay, that concludes this part.
All right. So we have a couple of questions. We only have 15 minutes, and maybe we have to ask only one. So one of the students is asking if Corda would somehow encourage companies to form oligopolies, and if that is so, would it be like also it might be hard for authorities to track these negotiations or transactions that these companies are carrying out? Is this a concern or not?
It could be a valid concern. So yes, because let's say a Quadra business network is a club with membership. You could form an oligopoly with it. Hopefully, I hope, and for example, in this insurance case, it's not intended. as, for example, we want to give many insurers access to reinsurance. That's like a stimulus for the market. And if the access is easy because you just need to join the club, then you've got the software, you've got the protocol, you can immediately contribute, then well, the tendency is rather than increasing the network than keeping it small.
Mm-hmm. Okay. And also you mentioned that it's very important for Corda to keep privacy of everybody. And indeed, the transactions and how many you've made should be kept private as well. But then the student is asking, how does this work when you are metering or billing? Aren't you leaking information in these cases when you're doing these actions?
Right. So let's say the business network operator runs a meter in form of a metering notary. So every transaction gets notarized, and while notarizing, the operator that's running on a quarter makes a tick into a list and counts number of transactions. The billing could also be by looking into contents of transactions when there's a quad up that involves the notary with starting the quad up and looking at the content. But this is really where, again, in the governance, this must be regulated in the organization rule book. So what will be done? What are the methods of metering? But certainly, like if I've got a validating notary, a notary that runs quad ups, then this notary will have possibility, depending on the quad up, to look at the content of transactions. One other approach, and this is what I'm going to mention shortly, like in the next round, is metering and billing inside of a secure compute environment. Talking about that now.
Okay, great. So that's all. Thank you.
Okay. So very shortly about opportunities. I hope I can stick in the time. A very interesting aspect of Quarter is the Quarter network, and there with a capital T, because it's something like the public, well, if you can name it like that, the public Quarter network. The idea of the Quarter network is the following. Quarter, and they founded the Quarter Network Foundation. So it's like a foundation, not controlled by R3, is operating the Quarter network. And the Quarter network basically means they do a certain level of KYC, identity check, with a dormant service, and issue certificates for members of the Quarter network. So if you want to be a member of the Quarter network, well, you get the software, you get the Quarter software, you contact the network foundation, the body, and ask them to issue you a certificate for a certain identity. They will verify your identity. So if I say I want to have an identity for Allianz, they would verify that I am Allianz by making phone calls on the Allianz number or whatever. But so they will verify your identity, and with that identity, you can start your node and get your private certificate signed by the doorman, and with that you're like a recognized member in the network. They provide a notary cluster and they provide a network map. So with the network map, you would find out in Quarter if you know another entity by name, by identity name. The network map maps this fully qualified name, X500 name, to IP address and port. So you would know how to connect to the other node by making a connection to them. So that's the network, the Quadra network, and inside the Quadra network, we've got different business networks. So, for example, B3I is a business network for reinsurance, where we've got nodes operated by insurance companies and reinsurance companies. But there's also, and there can be other business networks inside of the Quadra network. And for example, let's say there's a supply chain network and there's a finance network. Now, if one entity is part of the supply chain business network and the insurance business network, means it has like supply chain quad-ups available and insurance quad-ups available, then this can start as a bridge between for insuring supply chain items. So you could have a transaction that takes some existing states from the supply chain and builds them into some insurance states. And with that possibility, while combining these networks, then many different business possibilities are now opened. And so as an example, if B3I wants to expand to some financing, money transfers between the members using a finance network. Like if the members become part of the finance network as well, we already know that the nodes that they're running are compatible. So software-wise, we can connect to them and we can transfer transactions. And if we've got the right quad-ups in this network and we know the addresses and the memberships, we can then do transactions with members of different business networks. And this is very promising because it offers unforeseen scalability in business. Very, very important. It just comes as, a byproduct, let's say. Okay, current state of B3I, we talked about that. There's not so much new. The CAT XOL products has gone live with the first contracts. The network is now expanded with new parties. And what's called the fluidity tool is now going to be released in beta for additional parties, which could be also developers and service providers, to provide solutions for the B3I network. And there's like, I think recently there was a hackathon sponsored from B3I to get more ideas and solutions onto the network. On the Quadra side, what I mentioned, this Quadra conclave is it's a solution where you can run JVM processes inside of this Intel SGX software guard extension enclaves, which means you've got like a secure computation environment that cannot be looked at or intercepted from outside. And within this secure environment, you can have some kind of trusted computing, for example, for metering transactions at a notary without the provider or the owner of the notary node even having the chance to look inside what's going on and what's the content of the transactions that get in, because it gets in SSL into this secured area, SSL encrypted, the secure computation happens and the results are getting out over the SSL encryption, and it's not observable from the operator of the physical machine. Also very exciting. And then also Quadra, they showed already on QuadraCon some new developer environments for Visual Code, hosted Quadra IDE, and even like if you know Truffle for the Ethereum world and Ganache, then they've got even like a Quadra flavored Ganache that you can use for Quadra development. And again, shows me a little bit. So this direction is that even the guys that are looking at Quadra at Ethereum, in the Ethereum world, might be a bit excited to move and explore the Quadra world. Okay, now just lots of opportunities also for startups that I see. I just say examples. You could think about oracles that state that certain natural catastrophes really happened and when. So as a single source of truth. Risk valuation, and this is like better underwriting. There could be some specialized services that, for example, look at satellite images to set up better insurance models. There could be new approaches to sales, underwriting as a service. As I said, SGX enclave, claims handling, fraud detections, you name it. And this all would be enabled by the fluidity framework and by the conclave. And this comes now to the big summary. Blockchain enables to split up business processes into single parts. And these single parts can be dealt with by different entities, and blockchain can ensure that everything fits together and can guarantee the integrity. But blockchain, as I see it, and this is now blockchain in general, opens up business processes to new specialized participants. And I think that's the big challenge that comes in fintech and in insurtech with blockchain. Not everything that's done in Allianz today needs to be done in Allianz or by Allianz in the future, because there might be some more specialized niche players that can do certain parts of the whole business process better. And maybe with a blockchain-based infrastructure, then such players would find their role in the complete process. That's my summary. And last set of questions.
All right. So there are no new questions on the feedback. Therefore, maybe we can end the guest lecture here. So, yeah, thank you very much.
Then thank you very much for your presentation, Mr. Kiba. That was really interesting. We continue next Tuesday with our next guest speaker about zero knowledge proofs. And on Wednesday, we will have the final session for the exam, where you can bring all your questions and talk about how the exam will look like. Okay, then thank you very much again, and goodbye also from my side.
Thank you very much from my side, and well, good luck and have fun with the blockchain. Bye-bye.
Thanks,
bye-bye.